All right, 1.1.29 says the graph shows the jumper's height, y in feet, x seconds after getting onto a trampoline. Use the graph to answer parts A through D. So create a slightly larger image over here so I can mark this up a bit. But they're asking us for what are the x and y intercepts and then explain what those represent. This graph at first is a little difficult to interpret. We have to be careful with the measurements for each kind of tick mark along the x and y axis. So each one represents 0.125, which is quite annoying. So I'm going to fill some stuff out here. This here is going to be 0.25. This one here is going to be 0.75. And then we can just kind of continue across. So here we have 1. Sorry, I made that too small. Here, this mark is 1.25. This one would be 1.75. And then this here would be 2.25. All right, so that might help us a little bit to keep track of where the marks are. So what we want is we are looking for the x-intercepts. So my first x-intercept is right over here. I'm going to put blue dots there. And it's really difficult just by the eye test to see where exactly that is. But I'm going to mark each one of these. So we have 2, 3, 4, 5, 6. We have 6 x-intercepts in this case. Now, I have no idea just looking at that graph exactly what that blue dot would be, that first one. But if I go to my choices over here, 0.05 is a pretty small number, and that's pretty close to 0, so that'll work. My next 2 intercepts look like they're just to the left and just to the right of 0.75, and that would be 0.7 and 0.8. And then the same thing, the next group, they're on the left and right of 1.5. So 1.45 and 1.55 would be pretty accurate. And then finally, just before 225, so 2.2 would work. If I look at 1.7, there's nothing in this area here. So that's not going to be an x-intercept. And then negative 0.5, well, that's not going to work for me either. That's on the left side of the y-axis. So I'm going to use that as my selection. I'm going to check that. We got those correct. Now they want to know the y-intercept. I'm going to put this one in red. My y-axis, it looks like there's only one. It's somewhere in this range. All right, it's probably down there by negative 0.5. And if I check my answers, all of them are positive except for option F. So that's the one I'm going to use. All right, again, it's kind of difficult to tell exactly where it crosses the y-axis, but I do know it's a negative y-intercept, and that's my only choice. So we'll check that, and we're good. Now, what do x and y intercepts represent? The x value going across, that's time, right? That's how much time we've spent. And then the y value is the height in feet. Now we have to ask ourselves, how would somebody have a negative height in feet on a trampoline? Well, when you jump on a trampoline, there's some kind of sag, right? It'll have some give to it, and you'll go below the kind of the rim of the trampoline, right? So my y-intercept, that negative one, is kind of when the trampoline's bearing my weight. It's going to go below its normal position. And then as I jump, obviously the trampoline's going to go back to where it is until I land and push that back down. So my x-intercepts represent, they're not going to represent the sag, not part A. Represent the moment the jumper is at the height of the frame. So that looks like it's a possibility. When the jumper is increasing in height, that's not going to work, and the x-intercepts represent the highest point the jumper is at. Well, the highest point would be at the peak of my curves. So option B works. And then the y-intercept represents the sag of the trampoline when the jumper pushes down at the start of the first jump. So we'll go with that. We'll continue on. Now it says, over what intervals is the graph positive? Explain what the positive intervals represent. So the graph is positive, or the function is positive, anytime it's above the x-axis. So these curves here, where it's above the x-axis. My tracing's not on point today. But any point here, these are all positive intervals. Right? And then they'll eventually ask us what that means, but let's go with that first. So again, that's going to go from that first intercept, so 0.05, up until 0.7, and then it's going to start again at 0.8 to 1.45, and then from 1.55 to 2.2. So those will be my intervals where it is positive. We'll check that. We're good. Move on. What do the positive intervals represent? So what happens when we're at that curve? We're above the frame. All right, that's when we're jumping on the trampoline when we're in the air. So the positive intervals represent the time when the jumper is above the frame of the trampoline. Over what intervals is the graph negative? Well, the other portions of my graph, right? That's this first part, this little peak here and here, and then this part here. So from 0 to 0.05, that's that first portion. Then from 1.45 to 155. Then we're looking at, I missed one, sorry, 0.7 to 0.8. And then finally at, what is that, 2.2 to 2.25, that last portion. So we have 4 sections, so we should check off 4 of the parts. Good, moving right along. And what do the negative intervals represent? So we're negative relative to the frame. That means the trampoline is sagging down. So the negative intervals represent the time when the jumper is below the frame of the trampoline. So we'll check that. We're good there. And now the final part of it, they're asking you for the average rate of change over the interval 0.75 to 1.125. So 0.75, I'm going to erase some of this so we can see this better. Not that part. All right, so from 0.75 to 1.25. So 0.75, we're down here. And then to 1.125, we are right here. So along the graph, that's going to go all the way up to here. All right, explain the meaning of the average rate of change and the average rate of change of the interval, so you'll figure the rest of that out. That's going to be your 2 points are 0.75, negative 0.5. Again, that would be that first point there. And then, or they give us 1.125. Oh, sorry, we got to fix that. That's not that point. 1.125 is here. So that's going to be way up here at this peak, which we have to figure out is, so that's 1.25. So that's going to be at, where they're going up by quarters. So that would be 1.75. Again, this graph is not easy to interpret. So we'd have to figure out those points. Now we have our x1, y1, our x2, y2, and we can figure out what the slope is, or the average rate of change. So explain the meaning of the average rate of change over the given interval. So let's plug these in here. Negative 0.5 minus 1.75 over so negative 0.5 minus 1.75. So, oops. We're going to get, this can be negative 2.25 here, and then 0.75 minus 1.125 is negative 0.375. So we're going to reduce that. Okay, we're using a calculator here, make our lives a lot easier. That's going to reduce to 6. All right, as crazy as that sounds, that's going to be 6. So the average rate of change over the given interval is about 6 feet per second. The average rate of change over the interval, so now they're giving us, represents that's going to be the speed. All right, we're talking about 6 feet per second. So represents the average speed of the jumper and here we're going up on the jump. So that's going to be the upper part of the jump. So we'll check our answer. We got that right. This part right here, this is definitely going to be the hardest part. And the most complicated part of this is figuring out, what are the actual points they're talking about. This graph is not very well designed for us because those little marks are, it's hard to figure out. It's very easy to make a mistake on what each one of those little units on that graph is. So be careful with that. These type of problems, you definitely want to take your time. You need to look at the graphs very closely, and marking up the graphs always help. So if this was ever written out on paper, you definitely want to mark this as much as possible.